Okay, folks, let's talk atomic radius. So atomic radius is really telling us how big the atom is for any particular element. The definition is given to you here on the slide. It is the radius from the center of the nucleus to the outside of the outermost electron orbital. As we move down a group, or as we move from the top of the periodic table to the bottom of the periodic table, the atomic radius increases. Why is this, folks? And so to answer this question, let's take a quick look back at this version of the periodic table. So as we move down this group, we're going from a 1s orbital to a 2s orbital to a 3s orbital, for example. And so what that looks like in an atom is we have the 1s orbital around the nucleus, and then the 2s orbital, and then the 3s orbital that they kind of stack on top of each other. So it makes sense that atomic radius is increasing down a group from the top to the bottom of the periodic table, because the s orbitals, these spherical s orbitals, just get bigger and bigger and bigger. However, as we move from the left-hand side to the right-hand side of the periodic table, atomic radius gets smaller. So atomic radius decreases across a period. Or, as the graphic is showing you here, it increases from right to left. Why does it make sense that from left to right, the atomic radius decreases? Well, it's not particularly simple, at least at first glance, because as we move from left to right here, folks, for example, let's take the 2s row. We have the 2s, and then we're adding 2p. So you see that we have 2s and 2p. So you might think, as in our previous discussion, well, we're adding more electrons. Shouldn't the atomic radius continue to get bigger and bigger and bigger? The answer here, folks, is no. Why? So as we add more and more electrons into these atoms, don't forget the atomic number is increasing, the atomic mass is increasing. So as we add more electrons, we're adding more protons as well. And so what's happening here, folks, is you're getting more and more and more positive charge in the nucleus and more and more and more negative charge in the electron orbitals. And this acts kind of like a magnet. The magnet gets bigger and bigger and bigger. So across a period, what's happening is there's more and more kind of attraction between that positively charged nucleus and the negatively charged electrons. You can think about this in terms of like maybe everyday life experience. If you have two very small magnets held up next to each other, you won't really feel the attraction so much. But instead, if you're holding two very large magnets, you can physically feel the magnets pulling into each other. This is exactly what's happening across a period. So the increase in positive and negative charge increases attraction between the nucleus and the electrons. And this is what makes the atomic radius decrease. And that wraps up our understanding of atomic radius. Next up, electronegativity.